Hello everyone, this is my video for Constant Velocity Lab 1 for Physics 2211. My name is Kunal Aneja, and this is going to be the study of constant velocity. A little introduction about the lab is that it is over Newton's second law and its study on constant velocity, also known as the momentum principle. The formula is the final velocity is equal to the initial velocity plus the net force times change in time, all divided by mass. This is the Newton's second law, and it's in relation to Newton's first law that an object in motion will stay in motion unless there is a change in an external force. In this lab, we will be studying constant velocity, which requires no net force. And this new formula can be derived with the final is equal to initial times average velocity times delta time. The computational model was recorded on a application called Tracker, while the video of an object rolling was recorded on a phone. The system is shown by a camera, and the rolling object is moving with a constant velocity. I recorded each frame and numbered each one of the positions in the object. There are no other forces. For example, friction is ignored for this current computational model. To get the object moving, I used a ramp, which can be shown as the notebook, sloped notebook. However, that is not recorded and not measured as shown in this video. As you can see, the starting position is occurred at the end of the ramp, hence that initial force is not calculated when running all the calculations. The graph is upward sloping as the origin is to the left of its starting position, and that causes the object to moving in the positive x direction and the graph to be shown in the positive first quadrant. So the mass of the object is 0.03994 kilograms, and the initial position of the object was calculated using Tracker, and the initial velocity was calculated getting the average x position from the first two data points. The mass of the object initially does not matter because there are no net forces, and it's canceled it out. The graph on the left shows the position versus time graph. As I mentioned, it is a positive x, showing an increase in position over the 2-second period, and the velocity is the derivative of the position in time graph, which is a constant value as a linear line is shown. These two pictures match Newton's second law, and the time was matched in each of them. I also changed in the code to match Newton's second law, as ball velocity equals ball velocity plus net force divided by ball mass times delta time, and the ball position also changed for each part of the second, where the ball position equals ball position plus ball velocity times delta time. This is the experiment versus model graph. The line in blue is the observed x position, and the line in orange is the model's position. As you can see, nearing the origin, both lines match each other. This is because there are the model was calculated using the initial points, and however, as time goes on, it differs, and this could be done to external forces like friction. And this is in relation to Newton's first law as an external force is being applied. And you can see that they are both positive x values. However, the model has a greater slope than the observed x position. The what if is when I analyze the video data, I put the origin on the left of it. If I were to change the axis, then the slope of the model graph would change, and this would, for example, if I were to put the origin to the right of where the ball was rolling, then the results would flip in direction with having a negative sloping graph instead of a positive sloping graph. And for the question of what does it mean, you can't determine the forces that are acting on it because it has zero net forces, and since the forces cancel out, you won't be able to determine which forces are added together to give a net zero force. Thank you for watching.